board crashed when I was done. All right, so the first one, again, it's really hard to read the numbers on the axis, but at least you can count from the origin to figure out how far over it is. This is just a set of scattered plots. Scattered points all about. They're not connected. Okay, so when you're doing your domain and range, you're not going to do like parenthesis, bracket, comma, because it doesn't go from a number to a number. It's just a bunch of random numbers that are plotted. So anytime you see a scatter plot for the domain and range, you're actually going to do a list of values. You might remember we did this back in like a mapping diagram where we would list the x values and the domain and the y values. Now some students are able to, and when you do listings, you use the brace, which some of you are really bad at drawing, but do your best. Don't use a parenthesis or bracket because that indicates if it touches that number or doesn't. Some of you can just go on the x-axis and say, oh, it touches at -3, -2, 1, and 4. Others of you are saying, I don't know how she got that. And if that's the case, you want to go to each point and write the ordered pair first and then look at the x values. So this would be -3, -4. This would be -2, 5. But if you don't have to do this, you're not required to. 1, 3. 1, -2. Whoops, that's a 4. 4, 0. And then in the domain, that's x values. You will list all the x values from least to greatest without any repeats. So that would be our -3, -2. 1 shows up twice, but you only write it once. And 4. Again, braces are just a listing of numbers. Okay, for our range, we'll list the y values, which are -4, -2, 0, 3, and 5. Is this a function? Lily? No, it fails the vertical line test right here. Okay, the next one we have like a shape on the graph. These are little segments connecting to make this shape. But because these are connected, these are all like a bunch of solid dots, basically, that are going around the shape. So for domain, remember we want to go from left to right. So what's the smallest it touches on the x-axis? How far left does it go? -1, 2, 3. So we'll put bracket -3 because it actually touches at -3. What's the largest it gets on the x-axis? +3, right? Another bracket. Now if you're someone who likes the inequalities better, when it's in between the values, you have to use a compound inequality, so it would look like this. -3 is less than or equal to x is less than or equal to 3. So, because it's not continuing on forever, it's kind of bounded between two regions. I don't care which one you use. All right, now our range, the smallest it ever gets is -1, 2, 3, 4. Bracket -4. Highest it ever gets is 1, 2, 3. It actually touches at 3, so again a bracket. If you're doing inequalities, that would be -4 is less than or equal to y is less than or equal to 3. Use x for domain and y for range. Is that a function? Does it pass the vertical line test? No, it would fail the vertical line test multiple times. All right, now number 3, we have something new. We have this open circle, which is called a hole in the graph. Okay? Just like when we used to graph like x is greater than 3 on a number line, we put an open circle at 3 and shape to the left, because it can't actually be this number. So whenever we're doing our domain, and we go all the way to the left, -1, 2, 3, 4, we're not going to use a bracket, because it doesn't actually touch at -4. We'll use a parenthesis. If you're doing inequalities, you just won't put an equal bar. So if you like this method better, you wouldn't put an equal bar underneath it. All right, so then look, it comes over, there's a closed circle, it keeps going, closed circle, keeps going, and then we have an arrow showing that it's going forever and ever and ever. So it goes all the way to infinity. Infinities always get a parenthesis because we don't know what infinity is. Now the range, bottom to top. The smallest it ever touches on the y-axis is at 1. There's a solid circle and there's a segment, which is a bunch of solid circles. So it would be bracket 1. Now here's where students get confused. They go up and they're like, but it doesn't exist at 3, which you're right. Over here it doesn't. But if you come to this side, it does touch 3. So I always tell students closed circles have priority over open circles. So if you have both of them, it does exist. That would be part of your range because it exists right here. And it continues up forever on this side. Even though it doesn't on that side, it just needs to go up at one point. So this would be infinity. Is that a function? Yes. All right, I would like you guys to do 4, 5, and 6 on your, well, with your partner or on your own and then compare with your partner. Do all 3 of them. And then we're going to do the last 3 together because they're a little bit harder. All right, the last 3 then, number 9 being the hardest. Let's start there, actually. Put some stars around it. We have, in this one, a couple open circles. Okay, so you're actually going to have to link together pieces of the domain to skip over the whole. So you're going to be using a U, which stands for union. Union break. It will unite multiple things together. So like if the values are allowed to be from 1 to 2, and then they're allowed to be from 2 to 3, but they can't actually be 2, you can skip over a number by uniting them. Okay, so we'll start for domain, left to right. So the furthest left it can ever go is forever. Forever into the negative would start out negative infinity. Travel along. We get to negative 3 and there's a hole in the graph. So I'm going to put comma negative 3, but would I use a parenthesis or a bracket if it doesn't actually touch that number? Okay? A parenthesis. Then we're going to put the union symbol, which again is going to unite another piece of the domain. So we'll skip over 3. So we'll do another parenthesis 3, not a bracket. We never have a bracket because it never equals negative. That should be a negative 3, sorry. All right, and then notice this is a solid line from here all the way up to here, and then there's an open circle at 2. So we'll say comma 2. 2 doesn't get a bracket because it's an open circle, so we'll use a parenthesis. Sometimes you'd have to unite 3 pieces. So if there were multiple holes, sometimes you have to unite and skip over multiple pieces. But the union is used right around that skip, okay, the number you're skipping past. All right, our range. And the range is actually a hard part too for a lot of you. The lowest it ever gets is at negative 2. Some of you will put a parenthesis around negative 2, which is wrong. I agree that there's an open circle there, but do you see how there's a solid line? A solid line has closed circles. Closed circles overpower the empty circle if they're on the same number. So it actually touches at negative 2. It gets a bracket because of the line. If there was just a hole at the bottom by itself, it would have a parenthesis. But since there's solid circles, then travel up. Okay, we get to 1. There's a hole over here, but it goes up over here. So there's a closed circle. So when comparing those, this one overrides the other one, and it continues up. So that would be infinity. A little tricky. Is it a function? Vertical line test. Yep. All right, let's go back to 7 and 8. 8's also a little tricky. 7's what we've been doing, right? This is a square root. This is your positive square root. This is your negative square root. So this would be like plus or minus square root of x. That's what we have graphed. Who thinks they know the domain? Maybe someone I haven't heard from yet. The domain. What's the furthest it goes on the x-axis? Smallest and largest. Left to right. Marissa?
0 to infinity.
Good. Bracket 0 to infinity. Or if you're an inequality person, x is greater than or equal to 0. Range. Tracy? All real numbers. Down forever, up forever. Or negative infinity. Is this one a function? No. Because of the plus or minus, it is not. And then 8 is real confusing. It looks like it has 2 rays. And in case this doesn't show up on your paper very well, maybe trace it. This is what it looks like. So what do we think about the domain? How far left? How far right? Nick? Negative infinity to infinity. Okay, it goes left forever. It comes to negative 1 and stops, but then it picks right back up at negative 1 up here and continues on. Or all real numbers if you prefer. The range is the hard one on this one. The range is not continuous. Like on all the other ones, we were going up forever and it was a line. There's nothing connecting these. So if you think about what y values exist, this is 1, 1, 1, 1, 1, 1, 1. Like if you were to list the points, this is negative 1, 1, negative 2, 1, negative 3, 1, negative 4. The only number that's showing up on that line is 1. Up here, the only number showing up is 3. This would be negative 1, 3, 0, 3, 1, 3, 2, 3, 4, 3. So you actually are going to list the range because there's only 2 numbers that exist in the range. So when we do our lists, we do the brace. And the values are 1 and 3. It's kind of like what we did in the first example with the ordered pairs, but this one happens to have a couple rays involved. And then, is it a function? Close, but no, good. So I'll let head shaking. It would fail right there. Now, if one of these were an open circle instead of a closed circle, it would be a function. All right. On the back, we're going to look at some equations without a graph on our graphing calculator. Okay. So at the top, I just have a little reminder from earlier. Remember that the domain is all real numbers except 2 cases. One is if you have a square root. You cannot have a negative under an even root. That's one of your exceptions. So if you remember, we used to say the radicand must be greater than or equal to 0. So in an example that was given to us, we would have 3x plus 3 is greater than or equal to 0 and solve for x. Subtract 3, divide by 3. The domain would be x has to be greater than or equal to negative 1. This is one that you can't really graph per se because the stretch is not inside, outside, it's inside. And then the other stipulation is that we're not allowed to have 0 in the denominator. So we would always say denominator can't be 0. Those are the 2 things that you want to memorize if you haven't already. So the denominator of this one is x minus 4. So x cannot be 4. When we do our domain for this one, since it doesn't have an inequality, you would say all real numbers such that x cannot be 4. So remember on the front how we had like a hole in the graph and we had to skip over it? There would be a hole in the graph at 4. There would be an open circle. The other way you can write this, which I don't think any of you will want to, would be negative infinity to 4 union 4 to infinity. But I'm thinking the first one's a little shorter. But that's because it would skip over 4. Okay, so we're going to do 10, 11, 12, 13. We'll skip 14 and 15 without our graphing calculator. You may want to draw a sketch to help, because I know most of you like the graphs better than the algebraic. What shape would number 10 make? Would it make a line, a parabola, a sideways parabola, the S shape, a V? Joey? I didn't hear you. It would not make a line. Squared? Mm-mm. Nick? It is a reflected parabola. Anytime you see an x squared, it should make a parabola. Anytime you see, so if you see this, y equals x, that should make a line. If you see y equals x squared, that should make a parabola. It might be flipped or whatever. If you see y equals x cubed, that would make the S curve going upside down. If you see y equals the square root of x, that should equal half a sideways parabola. And if you see y equals the cube root of x, that's your sideways S curve. You need to know those without a calculator, just a general idea of what they look like. So since this one has an x squared, it's a parabola. Nick's correct, it has been reflected downward. What's the +2 tell me about the parabola? It would be shifted. Mick? Close. It's not in parentheses. So up to. So up to, negative tells you it's been flipped downward. Doesn't have to be perfect, we just need a general idea. So what should the domain be? Left to right. Crazy? All round numbers or negative infinity to infinity. Also think about the rules we just said. Is there a denominator? No. Is there a square root? No. So it should be all round numbers. That logically makes sense with the rules we have. Now the range, you do kind of need the graph to help you. Okay. The lowest it goes is negative infinity. The highest it goes is 2. If you're an inequality man, it would be y, or woman, is less than or equal to 2. Now the next one is a square root. We know it should look like this, but you need a little bit more than that for the graph. We can use our knowledge from yesterday, because it has this 4 underneath it, but do we see a GCF under the radical? Sure we do. You can then take the square root of 4, which is 2. What do you think we do with the two numbers outside? Multiply them. So we're going to end up getting negative 6 square root of x plus 4 plus 3. So I heard someone say it's a stretch. It is. 6 is a stretch. What's the negative do, though? What's the negative do to the graph? Last time it flipped the parabola upside down. So this time it's going to flip the half of the parabola upside down. So instead of counting like up 1 over 1, or whatever, you'll go down 1 over 1. Plus 4 inside is left. Plus 3 outside is up. So we're going to go left 4, up 3. That's our starting point. Again, if this were a positive, we would go up. But since it's a negative, we'll go down. Normally, if we were actually graphing, you'd count down 6 over 1. But we're just going to sketch it. It doesn't need to be perfect. Who thinks they can give me the domain? Left to right. Left to right. Who haven't I heard from? Madison. So the smallest it gets on the x-axis, and what's the biggest?
-4.
Mm-hmm.
Yeah.
Goes forever, right?
Yeah.
Infinity. Or x is greater than or equal to negative 4. Range. Bottom to top. Bottom to top. Joey?
Negative infinity to 3 round.
Negative infinity to 3. Perfect. Number 12 is a cube root. So remember the cube root, we don't need to do a table of values or anything. You just need to sketch the general idea that a cube root goes on forever. Also, a cube root is not an even root, which was one of our restrictions. So the domain should be all real numbers because it doesn't have an even root and it doesn't have a denominator. And it also, the range, down and up forever. Love cube roots. Love linear, love cube roots for domain range. And then number 13, which is the last one we're going to do. Notice I don't ask you for the range. We haven't learned enough to do that yet. That's chapter 9. We'll be graphing these types of functions. But without your calculator, you can't do it right now. So what should the domain be for this one? Do we have any restrictions on the domain based on the two rules we have at the top? Nick? X cannot equal -2. That is correct. How we found that was by saying that the denominator, what's in the bottom, cannot be 0. Otherwise, it's undefined. So we said 2x plus 4 equal to 0. Subtract 4. Divide by 2. Domain is all real numbers except -2. It would have a hole in the graph. It would have one of those like open screws. All right, I'm going to pass out your homework, which is a worksheet tonight.